Good evening, students. Welcome to our YouTube channel. This is Python video lesson number 25. In previous lesson, that is Python video lesson number 24, we studied about function. 4 types of functions. They are Lambda function, and then recursive function, user-defined function, built-in function. Out of these 4 types, we studied 2 types. One is user-defined function, then built-in function. In previous lesson, some of my students messaged me, they could not understand how to convert one decimal number into binary, octal, as well as hexadecimal. First, we will see how to convert one decimal number into binary, and then octal, and then hexadecimal. Then we go for remaining 2 functions, that is recursive function and then lambda function. First, now we are going to study about number system. It's not only related to Python. This number system used in all the languages, either maybe C, C++, as well as Java, whatever may be the language, it is related to all the languages. First, we will see the number system. Then we can go for function. Number systems. So normally 4 types of number systems are there. Types of number system. First one is decimal. Second one is binary. Third one is octal. Fourth one is hexadecimal. First one is decimal. Second one is binary. Third one is octal. Fourth one is hexadecimal. Base of decimal number system. System is number 10. Global numbers. Numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. See it here. The number system which has base, it is called as decimal number system. See here, 10 numbers are allowed. That means 10 total numbers of digits are allowed. Either it may be 0, 1, 2, 3, 4, 5, 6, 7, 8. In normal life, in mathematics or normal life, we are using this decimal number system only we are using. Example, 987. This is one decimal number system example. 10987. Whatever may be the number, all the number should contain only 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's all. Whatever may be the biggest number, whatever may be the smallest number, that number contains only any one of these or collection of these 10 digits, 0 to 9. Okay, this is decimal number system. Since in this decimal number system, we are using 10 digits, 10 different numbers, 0 to 9. That is the base of the decimal number system is 10. In normal life or normal mathematics, we are using only decimal number system. Second one is binary number system. Binary number system. Base of binary number system is 2. Global numbers are either 0 or 1. That's all. Here only 0 ones are allowed. That is why the base of the binary number system is number 2. Example, it may contain 1001, or 1100, whatever may be. All the numbers should contain only either zeros are only allowed here in binary. Since this binary number system uses only two digits, zeros or 1, the base of the binary number system is 2. Octal. Octal means 8. So base of octal number system is 8. Since allowable numbers 0, 1, 2, 3, 4, 5, 6, 7. That's all. So allowable different numbers are 0 to 7. Since it has 8 numbers are allowed here, the octal base of the octal number system is 8. Whereas example 1, 7 or 6, 5, 6. This is not correct. Okay, since we are having 9 and 8. Hexadecimal number system. Base of hexadecimal number system is 16. Allowable numbers are 0, just like a binary decimal number system. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Until 9 all are same, just like a decimal number system. Afterwards A starts, comma B, C, D, E, F. Okay, so 0 to 9 as it is similar to decimal number system. After 9, A refers to 10, B refers to 11, 12, 13, 14, 15. Here we are using 16 different numbers are used in hexadecimal number system. That is why the base of the hexadecimal number system is 16. Once again repeat it. Number system. There are 4 types of number system: decimal, binary, octal, hexadecimal. In normal life, we are using decimal number system. Binary, octal, hexadecimal are used in computers. The base of the binary number system is 2. Allowable numbers are only 0 and 1. Other than 0 and 1 is not allowed. In octal, base of octal number system is 8. Allowable numbers are 0 to 7. Totally 8 numbers are there. Other than these 8 are not allowed. Hexadecimal. Base of hexadecimal number system is 16. Allowable numbers are start with 0 to 9, just like a decimal number system. After that, it will go for A, B, C, D, E, F. Okay. Example we can go. This may be a 1 hexadecimal system. That means number 1, then 10. It refers to number 1, 10. Instead of 10, it should be mentioned as a. Then 9F. That means 9, 15. It refers to 9, 15. Now we will see how to convert conversion of decimal numbers decimal to binary. Conversion of decimal to binary. It's very simple. Consider we are having one decimal number. For example, 17. This is base 10. Okay. Now I like to convert this 17 into binary. That means this 17 should be continuously divided by 2. Since we are converted into decimal to binary, the base of the binary is 2. So this 17 should be continuously divided by 2. Modulus 2. It gives remainder 1. Integer division and then remainder. First integer division, first we will say remainder. 17 modulus of 2. We will get number 1 here. So 16 is there, it will give 8. Similarly, Again, this integer division should be divided by 2, that is modulus by 2. It gives here 4, here it will be 0. Again, this integer division should be divided by 2. It gives 2, remainder will be 0. Again, this 2 should be divided by 2. It gives here 0. Remainder will be, integer division will be 1. Remainder will be 0. So that's all we got to stop it here. So base decimal equivalent of binary equivalent of 17 is, we have to start from here, last integer division to remainder. 1, we have to go from bottom to top. We have to include this number 1 0 0 0 1 0 0 0. Understand? So binary equivalent of decimal 17 is 10001. You can confirm it, 10001. Similarly, we can find out conversion of decimal to octal. Conversion of decimal to octal. Here 17 we are having, one decimal number we are having. This decimal number here we are going to convert into octal. So base of the octal is 8. So this 17 should be divided by 8. Integer division is number 1. 2. Remainder will be 1. Already we know 2 8s are 16. Remainder will be 1. That's all. We have to stop it here. Here octal equivalent of decimal 17 is 2 1. We have to start from the last integer division and the remainder. Similarly, conversion of decimal to hexadecimal. Here 17, the base of hexadecimal is number 16. So 16, here 16s are 16, remainder will be number 1. So hexadecimal equivalent of decimal 17 is 1 1. That's all. This is not a binary number, this is hexadecimal number. We can try out for the bigger number also. For example, if 31 we are using, you can try out for 31. Instead of 17, it should be 31. Here 1 comes, here 15 comes. Okay, 1 16s are 15, remainder will be 15. Instead of 15, we have to write F. Instead of 15, we should write as F because the allowable numbers are 0 to F. 10, 11, 12, 13, 14, 15. Okay, so hexadecimal equivalent of decimal 17, it should be 31. 31 is 1F. Similarly, what about this one, sir? 31 modulus 2. So here it becomes 3 8s are 24. It becomes 3. Remainder will be 7. So 3 8s are 24. Remainder will be 7. Here it should be 37. Okay. Now we learn how to convert one decimal number into binary, decimal to octal, decimal to hexadecimal. Now I will write the same program once again to explain clearly how to convert decimal to binary, decimal to octal, decimal to hexadecimal. So first we should have one number. For example, it is x. First we'll try out 17. Then we can go for 31. Here printf binary equivalent x in binary, comma, format of x, comma, we have to mention ben. You can save the program and then I'll run the program. See it here. So x is in decimal form 17. Binary equivalent of number 17 is 1001. Then we can proceed for octal and hexadecimal. Instead of B, it should be O. O stands for octal. See it here, 21. You should not call it as 21, it is 21. Hexadecimal. Mentioned as X. X stands for hexadecimal. See it here, 1 1. You should not call it as 11, it is 1 1. What will happen, sir, if you are giving 31? See it here, it is 1 1 1 1 1. Octal equivalent of decimal 31 is 37. Hexadecimal equivalent of decimal 31 is 1F. Whatever we studied in the theory lesson, it comes in civil. Now you know how to convert or how to check decimal into binary, decimal to octal, decimal to hexadecimal. Now we will learn recursive function. It is a function which calls itself. The function calls itself. In recursive function, it is necessary to have one base condition. Recursive function calls itself again and again until base condition is false. Once the base condition becomes true, The recursive function does not call itself anymore. That's all. So function which call itself, it called recursive function. In recursive function, it is necessary to have one base condition. All recursive functions should have one base condition. This recursive function calls itself again and again until the base condition is false. Once the base condition becomes true, it will not call same function. Now I will write one Python program which is used to find factorial of given number. Already we know very well factorial. For example, 5 factorial. That means 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. Okay. Now I will write one program which gives result or find the resultant of the factorial of given number. Recursive function. If here we need one function may be n. So here if n is equal to 0, this is one condition. If the condition is true, no more execution, stop. That's all. Finished. Return 1. Else the function should call itself. Return n star n minus 1. Sorry. N star fact of n minus 1. That's all. Now we should have print of, first we'll have 0. See what will happen here. Fact of 0. Here, this is the print fact of 0. This fact calls this function. N is a parameter which is assigned by argument 0. Here 0 equal to 0. This is the base condition. This is the base condition. Now the base condition is true. Recursive function calls the recursive function again and again until the base condition is false. Now the base condition is true. So return 1. It stops here itself. It gives only 1. See it here. It gives number 1 only. Okay. What will happen, sir? Fact of 5. That means fact is a function. N is a parameter which is assigned by argument 5. Now 5 double equal to 0. Condition becomes false. This else block will execute. This else block will execute. Here return n multiplied again fact. Now n is 5. This fact is a function name. This fact of n minus 1, that is 5 minus 1, fact of 4. This fact of 4 again calls the same function. That means the function calls again same function. Recursive function calls itself. Here n is 5 multiplied by fact of 4. Now fact of 4 is says that 4 equal to 0, again condition for again it comes. Now result will be 5 multiplied by, it becomes 4. Again multiplied by, now n is 4. Previously n is 5. So 5 multiplied by 4 multiplied by fact of 3 minus 1. Now fact of 2, it will go here. Again it becomes here 5 multiplied by 4 multiplied by 3 multiplied by fact of 2. It goes like this. At one point of time, fact of 2 minus 1. Now fact of 1, it comes here. Fact of 1, it comes here later. So first it returns 5. Then it returns multiplied by 4. Then it returns multiplied by 3. Then it returns multiplied by 2. So 5 multiplied by 4 multiplied by 3 multiplied by 2, it will return. At last, fact of 1, it goes here. 1 is 1. 1 equal to 0. Again, condition false. It returns at last star multiplied by 1. 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Then 1 minus 1. Fact of 0 it calls. It's fact of 0. N equal to 0 equal to 0. Return 1. That's all. So we will get result as a 120. That means 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. You will see it here. So factorial of 5 is 120. This is the usage of recursive function. So recursive function calls itself. All recursive functions should have one base condition. The recursive function calls itself until the base condition is false. Once the base condition is true, it stops executing. That's all. Next, we will see lambda function. Lambda function. So the lambda function can be called as anonymous function, anonymous or unnamed function. It can be called as anonymous or unnamed function. So here, in remaining three, for example, user-defined function, built-in function, as well as recursive function. We are having one function name, but this is defined by keyword def. Whereas in lambda function, we are not using any function name. We are not using any function name. Without function name, we can create one function. Lambda is a keyword which is used to define lambda function. Now we will see the syntax. Lambda. So lambda is a keyword which is used to define lambda function. Parameter colon here expression. That's all. So here lambda is a keyword. Parameters are optional. Colon expression. I will explain with the help of one program. We can easily understand. Lambda function. So here display colon print success. This is one lambda function. Without argument. We are not using any argument here, or without parameter. Without parameter, because parameter we are not using. So similarly, here we can use it display alone. That's all. It calls lambda function. Here display equal to lambda colon. Okay. So lambda is the keyword, colon, this is the expression. So just consider we are calling display. This display calls this. This display is a function name which is assigned by this expression. That is print success will be assigned to display. We'll see it here. So success is displayed. Similarly, with the argument, sum equal to, it may be any number, sum equal to lambda. We want to add two numbers, so that should be passed here. x comma y colon. Here x plus y. So this is lambda is a keyword, x comma y is the parameters colon. This is the expression. Now we can call we are not displaying the values. Similarly, we can give negative value, print of sum of 10 comma minus 20. This is also a lambda function with parameter. This sum of 10 comma minus 10 calls this lambda function. X will be assigned with 10, y will be assigned with minus 20. Now sum will be assigned with 10 minus 20. Then minus 10 will be assigned to sum. It will return minus 10. The minus 10 will be print out. We'll sit here. See, okay, that is what is called as a lambda function. Today I stopped here itself. Today we learn how to convert one decimal number into binary, then decimal to octal, decimal to hexadecimal. Then we studied recursive function and then lambda function. Recursive function means function which calls itself. Lambda function means anonymous or unnamed function. Syntax for lambda function is no need to put diff keyword. Instead of def, we have to give lambda. Parameter is optional, colon expression. That's all. Today I stopped here itself. I hope all of you enjoy this lesson. In coming lesson, in next lesson, we will study a little bit more. Until then, thank you students. Bye bye.